so the first thing that we're going to talk about is the parent function. Okay, if something is a parent function, it's like the original. Okay, think about your parents, they're the original. You came from them, so everything else is a derivative of this absolute value of the x function. So we're not adding anything, we're not subtracting anything, we're not multiplying, dividing, anything like that. It's just a plain old, just absolute value of x. As simple as we can make it. Here in a little bit, I'm going to have you get your Chromebooks to use Desmos, but for right now, I just need you to kind of watch what I'm doing here. But here in Desmos, there are two ways that you can get your absolute value bars. You can use the shift and the button beside the backspace. That will start the absolute value bars. Or also down here at the bottom, which I can't get to right at the moment because that's in the corner of my screen. That's not gonna work. Okay. Can I move this? Nope. Really? Okay. Well, there's a little keyboard down here when you don't have this in front of you, and it has the absolute value bars are in it as well. So I'll show that to you sometime when I'm not trying to record my screen. But here's just a plain old absolute value of x. Obviously, key feature, our vertex here at the origin. And anytime you're wanting to graph something, you want to get some points to plot. Obviously, an easy one's -5, +5, +5, +5. Please do not talk while I'm talking. So we've got the origin. We can plot some points here. And we see that basic V shape that is very characteristic of the absolute value function. So you need to put that graph on your paper there. Hopefully it looks a little bit better than mine does. All right, so the vertex, it's similar to the vertex in a quadratic function. It is that either minimum or maximum point. So we can see that that is there at 0, 0. I don't have a place for domain on this function because the domain is all real numbers. If we look at it from left to right, there's no start, there's no stop. It's continuous everywhere. So the domain is all real numbers. Let's talk about the range though, because the range is not all real numbers. So we want to start at the bottom. We don't have anything until we get to the x-axis, which is a y value of 0. So remember two different ways that we can write this. We can either write that y is greater than or equal to 0, because all of our y values are above that value of 0. Or in interval notation, we would write that as a bracket with the 0 to positive infinity. Remember, it's always least to greatest, smallest to biggest. Our smallest y value is 0. Our largest y value is positive infinity. 0 does get a bracket because we do equal a y value of 0. Okay, told you we were going to review everything that we've done so far. So let's talk about where this function is increasing and where it is decreasing. We start on the left side of our graph. We're tracing it. It starts by decreasing. Remember, we want to put that vertical line where it changes and mark it with its x value, because the only time we use the y's is with the range. Okay? Now, if you would get lucky in this case, because at this point the x and the y are the same, but it is the x value of 0 that we're technically using. So this side is decreasing, this side is increasing. Remember, you're always moving left to right, just like you read a graph the same way. Remember, we want to put our negative infinity and our positive infinity down here as well, just because that helps us write our intervals a lot more easily when we put our numbers here in order. Negative values are on the left, positive values are on the right. So we are increasing from 0 to positive infinity. Thank you. Okay, we are decreasing from negative infinity to 0. All right, this was the new thing that we talked about yesterday, positive, negative, and 0. I'm sorry. Is it greater than 0? Is it less than 0? Is it equal to 0? All right, so this graph, we're looking, the x-axis is our cutoff point there. Okay, this entire graph is above the x-axis. This entire graph is above the x-axis except for where we are equal to 0. So we have a 0 at x equals 0, because that's where we touch the x-axis, but everywhere else we are positive. Remember, this was the weird case. We looked at one like this yesterday. We technically have to break that interval up at 0, because 0 is not a positive number. So we have to break this up at that x value of 0, because at x equals 0, right here, at x equals 0, we're not positive, we're equal to 0. And then negative, we have no negative intervals for this function. Now, that is not always true about our absolute value function. We're going to look at 2 more examples where things are a little bit more interesting than just the parent function. But this is the standard. This is the basis. This is where we start. Any questions? All right, let's look at one where we've got a little bit more going on. We have the absolute value of x minus 1 minus 4. So let me change what I've got here. I have a minus 1 inside my absolute value, and then I have a minus 4 outside my absolute value. Notice the shape did not change, but the location did change. So some key points, and this is another reason why I love Desmo so much, because it automatically points things out to you, points of interest. The vertex, it's got it labeled right there, 1, negative 4. So we can translate that to our graph, 1, negative 4, really easily there. Okay, let's see here. Shows us our y-intercept, 0, negative 3. Right there. It even gives us our x-intercepts. We don't have to do any calculating. We don't have to look at the table. We don't have to guess what it is. It's right there. All you have to do is click on the point. So negative 3, 0, and 5, 0. So now we've got plenty of detail. If you want more, you can of course plot more points, but I think that's sufficient to get an accurate graph here of our absolute value function. I do encourage you to carry it to the edges of the graph just to get as much detail as possible. So the vertex, we already mentioned that. It is 1, negative 4. I did mention it in passing when we did the first example. That is an absolute minimum. I haven't brought up that terminology in a couple of days, but let's just remind ourselves that is an absolute minimum. I didn't spell that. Yeah, I did. Minimum is an absolute, because that is the lowest point that we will hit with this function. Again, domain, didn't mention it because it's all real numbers. Okay, it's just kind of a given there. The range, the y values, start at the bottom. The bottom y value here is at negative 4. So y is greater than or equal to negative 4, or in interval notation, that would be negative 4 to positive infinity. I don't care which one you use, whether you use inequality or interval, as long as it's the correct answer. Whichever one makes more sense to you, you're more consistent with using, go with it. All right, increasing, decreasing. This one looks a lot like the one we just did. It starts by decreasing. Now, where it changes is at a different place. This one changes at an x value of 1. So we put our negative infinity, we put our positive infinity. It is decreasing first, then it is increasing. So our increasing interval is 1 to positive infinity. Our decreasing interval is negative infinity to positive 1. Again, notice I'm using the x value. I'm not using the -4 there. I'm using the positive 1. It's always, always, always the x. All right, this one is more interesting when it comes to our positive and our negative. Part of this function is above the x-axis, part of it is below the x-axis. I'm going to do this on the top of the graph. Since I already have this written down here at the bottom, I'm going to do this part at the top. I'm going to put some vertical lines here where it changes from being above to being below. So that changes at x equals -3. We were above, then we're below, and then here at x equals +5, we were below, now we are above. I'm going to put my infinities up here too, because they still apply. We're still going left to right. Okay, we're still going left to right. This first section is above the x-axis, so above is positive. This section between these two lines is below the axis, so that is negative, from -3 to 5. And then this last section right here, from 5 on, is above the x-axis, so that is positive. So then I can very easily just take my intervals. Positive from -infinity to -3. Negative from -3 to +5. And then positive from 5 to infinity. Where I'm equal to 0 is where I cross. It's those numbers, the -3 and the +5, are where I'm on the x-axis. Any questions? Hopefully it's all coming together, wrapping up nicely with this new function. All right, one more example just to make sure we've got it. This one has a negative in front of the absolute value. That's a little different than the ones that we've dealt with up to this point. We've got negative absolute value of x, what was it, +2, +3. Okay, so notice something a little different here. Same shape, it's flipped over. Okay, same shape, flipped over. We still want to identify those important points of interest, our vertex, our intercepts, and our x and y intercepts. So -2, 3 is our vertex. 2, 3. And we had an intercept at, was it 0, 1? Yeah, 0, 1, 1, 0, and 5, 0. Okay, those are the important points on our graph here. Okay, I went ahead and wrote down our vertex at -2, +3. Again, domain, still all real numbers. I'm just not writing it down. The range. Okay, this time my y values are below. They are less than or equal to my y value of my vertex at 3. That's the highest point that we're going to hit. Okay, this is a reason why I really like interval notation, because as long as you remember it's always either left to right or bottom to top. If we think bottom right here, we've got values down here at -infinity, and then our values stop at 3. You don't have to worry about which direction the inequality is supposed to go. For that reason, I prefer interval notation, but whichever one makes more sense to you. All right, this one increases first. This one starts by increasing. Where does it change? It changes at -2. It increases, then it decreases. So our increasing interval is -infinity to -2. Our decreasing interval is -2 to infinity. Positive and negative. Okay, still using the x-axis right there. Things are just kind of flip-flopped from the one we just looked at. You still want to mark where it changes. So let's see here, that's at -5 and at +1. Put your infinities in there, and then we'll identify positive, negative. Okay, so this first batch of our graph, or first part here, is below the x-axis, so that is negative. The middle part, between -5 and 1, the middle part of our graph is above the x-axis, so it is positive. And then the last part, from 1 to infinity, that last part is below, so it is negative. So now we've got our intervals, we just got to copy them down. Positive from -5 to 1, negative from -infinity to -5, and 1 to infinity, and it's equal to 0. I should probably do those first. Equal to 0 at -5 and +1. Those are our zeros. Our x-intercepts are our zeros.